compute sine square 13 degrees plus cosine square 13 degrees plus secant square 13 degrees plus cosecant square 13 degrees minus tan square 13 degrees minus cotangent square 13 degrees. And you have your answer also here. 5 options. Is your answer, is it -1 or +1, or is it a 2 or 3 or 1 minus pi over 2? So how do you do this problem without using calculator? As you see here, it is sine square 13 degrees plus cosine square 13 degrees. You have something to do with this. There is an identity, a Pythagorean identity. And even this thing, secant square 13 degrees and tangent square 13 degrees, you can handle those two together, and cosecant square minus cotangent square. So we have this Pythagorean identities, right? The first one is sine square theta plus cosine square theta is equal to 1, and second, it is 1 plus tan square theta is equal to secant square theta, and the third one is 1 plus cot square theta is equal to cosecant square. Alright, so first one, if I use the first one, sine square theta plus cosine square theta equal to 1. This 13 degrees and 13 degrees, the same angle what you have here, that is also same. Hence, sine square theta plus cosine square, in this case 13 degrees, together it becomes 1. Plus, here I have secant square minus tan square theta. Like here, like 1 plus tan square theta is equal to secant square. Hence, if I remove this tangent from the left hand side and take it to the right hand side, what happens? Subtracting tan square on both sides, we get 1 is equal to secant square theta minus tangent square theta. So secant square minus tangent is equal to 1, right? So this is secant square minus tangent square. Together, these two I can write it as 1. Similarly, cosecant square theta minus cotangent square theta. In this case, that is 13 degrees. It is just like an same angle. Is also 1. So what is the result? 1 plus 1 plus 1, that is equal to 3. So 3 is your answer. That's all. So if you look at a problem, it appears so much complicated. But if you remember your identities, make use of those identities, and you can solve it like this. Okay, thank you.